This is lab number 6, labeled diffusion. For this lab, you need a 60 milliliters of corn syrup, red and blue dye, a 9 centimeter petri dish, some tape, a ruler, and a stopwatch, which I will be using my iPhone. So the first step is use clear tape to secure 1/2 of the petri dish over a ruler. Make sure that you can read the measurement markings on the ruler through the petri dish. The dish should be positioned with the open end of the dish facing upwards. So we're going to take the dish, we're going to place it on the ruler. And then we'll take the piece of tape and we will place it. So we have something like this, where you can see the measurements. Carefully fill half a petri dish with corn syrup until this entire surface is covered. So we'll take the corn syrup. And we're going to cover it until the surface is full. I think that's enough. So we'll place the corn syrup aside. Develop a hypothesis regarding which color dye you believe will diffuse faster across the corn syrup and why. Record your hypothesis in the post-lab questions document. So I'm going to check and look at these. And I'm looking at the weight of the dye. Doesn't say in there, but I can look it up and develop a hypothesis after the experiment. Place a single drop of blue dye in the middle of the corn syrup. Note the position where the dye fell by reading the location of its outside edge of the ruler. And I think this is where we're going to need, okay, record the location of the outside edge of the dye, the distance it has traveled, and millimeters every 10 seconds for a total of 2 minutes. Record your data. Okay. So we're going to place a drop in the middle. And start the timer. The initial position is 4 centimeters, or I'm sorry, yes, 4 centimeters, and 10 seconds is 5 centimeters, 20 seconds, 4.5 centimeters, at 30 seconds it is 6 centimeters, 40 seconds, 6 centimeters. 50 seconds, it is 6.5 centimeters. And 60 seconds, it is 6.5 centimeters. So it stopped moving, it looks like. At 70 seconds, 6.5 centimeters. At 80 seconds, 6.5 centimeters. And we started at 4 centimeters, so this is only traveling 1.5 centimeters. And at 90 centimeters, it's still at 6.5. At 100 seconds, it is still 6.5 centimeters. 110, it is still at 6.5 centimeters. And at 2 minutes, it is still at 6.5 centimeters. So, in my table, at 10 seconds, it spread pretty rapidly from 4 centimeters to 5 to number 5. So technically it traveled 1 centimeter. At 20 seconds, it traveled 1.5 centimeters. At 30 seconds, it traveled 2 centimeters. At 40 seconds, it traveled 2 centimeters. At 50 seconds, it traveled 2.5 centimeters. 60 seconds, 2.5, and so on. And for the rest of the 120 seconds. So now we will take the tape off somehow. I'll try to get it off here with these gloves. I'm trying to be careful not to spill the corn syrup. And then we will repeat the procedure using the red dye and the unused half of the Petri dish. So I'll take that off. And we'll place the used corn syrup and dye aside. Then we will fill the other half of the Petri dish with corn syrup as well. But before we do that, we should tape the ruler to the Petri dish. So we'll get a piece of tape if I can get it. Just struggling with the tape, sorry. It's hard to do this with gloves on. There we go. It's starting to come a little bit. Oh, come on, come on. It's not a big enough piece. This is taking way too much time. I'm sorry. Just will not come up. It's trying to come up here, guys. There it goes. Now we're cooking with fire. So I have a piece of tape now after a good minute of struggling, and we will place the ruler on the Petri dish. Exact same what we did with the step before. Okay, so now we will pour more corn syrup, enough to fill the upper and cover the edges. Kind of ooze out. Try not to use too much of this. I think that's gonna do it. Alright, I think we have most of the surface covered. So now we'll get my time set up. I have my stopwatch ready, the red dye ready, and here goes the dye. We'll put it at 4. We'll start. So after 10 seconds, it's already at 6 centimeters. At 20 seconds, still at 6 centimeters. Still at 6 centimeters. At 30 seconds. At 40 seconds, it's at 6.25 centimeters. At 50, it is still at 6.25 centimeters. And at a minute, it is at 6.5 centimeters, so it's moving, but slowly. At 70 seconds, it is still at 6.5 centimeters. At 80 seconds, still at 6.5 centimeters. 90 seconds, it is still at 6.5 centimeters. A 100 seconds, it is still at 6.5 centimeters. 110 seconds, it is still at 6.5 centimeters. And at 2 minutes, it is at 6.5 centimeters. So it moved about the same as the blue dye distance-wise, but it did more rapidly, and as soon as it went out to 6 centimeters, so as soon as it traveled 2 centimeters in 10 seconds, it kind of just staggered and eased its way back out. As from 10 to 30 seconds, still that 2 centimeter range, and then from 40 seconds to 60 seconds, it moved about a quarter, and then another quarter, which ultimately gave us 2.5 centimeters is the total distance throughout the 2 minutes. So that is the diffusion lab. And yeah, I have my results. I'm gonna go write it up and put it on the lab report. I will make another video for the concentration gradients and membrane permeability lab that is up next, and I already have it set up, so we'll do that next and make a different video. Okay, so this is part 2 of Lab 6. This is the concentration gradients and membrane permeability. The materials that you need for this lab is 1% glucose solution, C6H12O6. You need iodine potassium iodide. You need liquid starch, C6H10O5. You need small rubber bands, a permanent marker, some tap water, some tape, 4 glucose test strips, 5 100 milliliter beakers, 3 pipettes, a 100 milliliter graduated cylinder, dialysis tubing, 15 centimeter piece of that. I have a timer on my phone and then some scissors. That's all we're gonna need for this lab. So procedure number 1, measure and pour 50 milliliters of water into a 100 milliliter beaker using the 100 milliliter graduated cylinder. Submerge the dialysis tubing in the water for at least 10 minutes. So I did that and it's been about 10 minutes. So measure and pour 82 milliliters of water into a second beaker using the 100 milliliter graduated cylinder. Label this beaker experimental with a permanent marker. Okay. Experimental. And we're going to place it on 82. This is the beaker you will put the filled dialysis bag into in step 10. Okay, so we'll take this, we'll get 82 milliliters. There's 82. And we'll place it in the 100 milliliter beaker. That's what it looks like. So we'll set that aside. Make the glucose sucrose mixture. Use a graduated pipette to add 5 milliliters of glucose. Okay, to a third beaker. So I think I should take out this bag since it's been sitting for a while. So I'll take out the bag. I'll take one side. We're gonna fold it. We're gonna kind of create an end here that won't allow any liquid to get through. We'll put a rubber band down towards the end. You need to do this a couple times just to get it tight. So that's kind of what that looks like. So we have a stoppage. At one point, we'll do it another time just to get it around the correct spots. Maybe do it one more time. Make sure it's really tight at the bottom. I think that's tight. So that's what this looks like. And we'll lay that down. Let it dry a little bit. So measuring pour, we did that. Make the glucose sucrose mixture. Use a graduated pipette to add 5 milliliters of glucose solution into a third beaker. Okay, so here is the glucose solution. We're going to take 5 milliliters. It's about 2.5. Here's about 5 milliliters of that solution. So we have 5 milliliters of glucose solution in our third beaker. Label it GS solution with the permanent marker. We have our GS. Use a different graduated pipette to add 5 milliliters of the starch solution. So this is the one we already used, so we can't use that again. So we'll use the starch. Shake before you use it. Put that, there's about half. And we should have 5 milliliters of glucose and 5 milliliters of the starch. So that's what that looks like. We're going to mix it up by pipetting it up and down a couple of times. Okay, I think we're mixed. Using the same pipette that you used to mix the dialysis bag solution, which will be this one. Remove 2 milliliters of the glucose starch solution and place it into a clean 100 milliliter beaker. Okay, 1, 2. There's 2 milliliters. And we'll put it in the positive control. Positive control. There's positive control. So we have 3 beakers right now. Dip one of the glucose test strips into the positive control beaker. After 1 minute has passed, record the final color of the glucose strip in table 3. This is your positive control for glucose. Okay, so we'll get the glucose test strips. We'll dip one of the glucose test strips into the positive control beaker. Okay. That's what that looks like, a glucose test strip into the positive control beaker. After 1 minute has passed, record the final color of the glucose test strip in table 3. Okay, so we're putting it in positive control. So while we're waiting on that, if 1 minute has passed, we're going to positive. Should take some results here. Color. Use a pipette to transfer approximately 1.5 of IKA iodine, which is this, iodine potassium iodide, into the positive control beaker. And we'll wait and see, and wait for a minute to pass and see what color that gives us. It's been about a minute. We got a yellow color. Now we'll take the IKI. Put half of them in the millimeter in there. We'll make sure we get it mixed around. And we'll see what color it turns. And after a minute, it has turned. We'll give that a minute to change color. So I think we use a different test strip for this. So whenever it was just the positive control, it was a yellow color. And now with the IKI, we'll let that soak and get a good result. So it's turning a little dark. It's like a little dark green color. With IKI, it is dark green. Using a clean pipette, remove 2 milliliters of water from the experimental beaker and place into a clean 100 milliliter. There's a clean 100 milliliter. We'll take 2 milliliters from here. We'll place it into there. There's 2 milliliters. Then we will label this the negative control. Negative control. So we have the negative control. We dip one of the glucose test strips into the negative control beaker after 1 minute has passed. Record the final color of the glucose test strip in table 3. This is your negative control for glucose. Okay, so we'll put the glucose test strip. Okay. So we'll check out the color. Yellow. Then we'll take the IKI, use the same pipette, and we'll put about 1/2 of a milliliter. Use a pipette to transfer approximately 1/2 of a milliliter of IKI into the negative control beaker. After 1 minute has passed, record the final color of the water in the beaker. Okay. Here's about 1/2. What should be substance? So this is coming into an orange color. There's the dark green that I was talking about, and then there's the orange. The color results of these controls determine the indicator are again key. You must use these results to interpret the rest of your results. Okay, so we have 4 beakers right now. We have the experiment, the glucose, GIS, positive control, and the negative control. So now we waited 10 minutes, have passed, remove the dialysis tube from the water, which we did. Close one end by folding over 3 centimeters on one end. Fold it again, secure with a rubber band. We did that. Dry off the outside of the dialysis tube with a cloth or a paper towel. Okay, we can do that. Just drying off the tube. I have the tube folded a lot at the bottom and with a rubber band at the bottom. So we're going to try the dialysis tube again. We're going to remove it from the water. And where you go, it opened up. So it is open. So we will take one side and fold it over 3 centimeters, fold it again, and we'll make the tube stoppage again. So we will do that. We'll fold the rubber band around about 4 times. So in the previous portion of the video, I had troubles getting it open, but figured out it has to be wet for it to be opened. So that's where the error was. So now we have an open dialysis tube. finally. So we'll take a pipette and we'll fill it. Let's see, dry off outside of the dialysis tube. Off, did that, and add a small amount of water in the bag to examine the rubber band to see if it will hold up. So it looks like there isn't any leaks. So we'll pour that back in there. And hopefully get most of the water out. So then, using the same pipette that was used to mix the glucose starch solution. And step number 4, transfer 8 milliliters of the glucose starch solution from the GS solution beaker into, there's a beaker shown in figure 4. Put it into the dialysis bag. There's 8 milliliters. Place the filled dialysis bag in the experiment, leaving the open end draped over the edge on the beaker, as shown in figure 4. Allow the solution, place it into the experimental beaker. So that's what we got. It's in there. Allow the solution to sit for 60 minutes, clean and dry material so for the beaker. After the solution has diffused for 60 minutes, remove the dialysis bag from the beaker and empty the contents of the bag into a clean, dry beaker. Presence of glucose by dipping 1 glucose tester. Sorry, I'm just reading the instructions here. Test for the presence of starch by adding 2 milliliters to the beaker. Okay. So we place the filled dialysis bag into the experimental beaker, leaving it draped open like that. After the solution has diffused for 60 minutes, remove the dialysis bag from the beaker and empty the contents of the bag into a clean, dry beaker. Label the beaker dialysis bag solution. Okay. So we will let that sit for an hour, and we will be back with more results. So 60 minutes later, we have the experimental beaker with the dialysis tube in it. So after the solution has diffused for 60 minutes, remove the dialysis bag from the beaker and empty the contents into a clean beaker. And so this is going to be the DP bag. So we'll label that, and we'll place the remaining liquids in that bag into here. Test the final dialysis bag solution for presence of glucose by dipping. So we will put a glucose test strip into the dialysis bag beaker, and we will actually give that a minute to change colors. So it didn't really change. It's still yellow. in the bag. Test for the presence of starch by adding 2 milliliters of IK to the beaker. 1 minute passed, record the final color. Okay, so we'll take the pipette. We'll add 2 milliliters of IKI. Get a color. That's what it's looking like. So we will let that sit. Looks a little brownish, dark. See, it's a very dark orange. Dark orange. Then we'll take a pipette, clean one. We'll take 8 milliliters of the experiment water and place it into a beaker. 2, 4, 6, and 8 milliliters. Put the experimental beaker into there. So we did that correctly. Test the beaker water for the presence of glucose by adding a strip. By dipping 1 glucose test strip into the beaker, wait 1 minute before reading the results to test strip, and record the results into table 4. So we will wait a minute. So that's been in there for about a minute. So it's yellow with a little bit of green. A little bit of green. Okay. Then we'll add 2 milliliters of IKA to the beaker water. There's IKI. It's a little bit more brown color. So comparing the two, this is a little lighter. The beaker water looks like an orange. Let that sit for a minute before we record the final color. So for the diffusion bag beaker, after 60 minutes, we tested it with a glucose strip and it turned yellow. And then we put the IKI in the beaker and it was a dark orange. And then we took the beaker water and placed it into another beaker, a clean one. And after 60 minutes, we tested it with a glucose strip and it was yellow with a little bit of green on it. And then whenever we added the IKI, it was a little bit, it's an orange. We'll put orange on there. We have the orange. And so those are my results. There's the full lab, all 16 steps completed. And after this, obviously clean up and put everything back away. Thanks for enjoying the lab.